Today's second video on trig identities, and we're going to prove a couple of harder ones here. So this one is obviously a little bit harder, just because you have sine plus cos all in brackets squared, and then the right hand side like this. So everything is already in terms of sine and cos in this one, so I don't have to do that step. And so the next one is either to expand or factor. And I can expand this. So if I expand that, I've got sine theta plus cos theta. And this is the whole thing squared, which means it's times itself. And equals my 1 plus so now you got this one here, you use FOIL to expand it out. Okay, so sine times sine, which gives me sine squared theta. Sine times cos, so can't do anything other than make it sine theta times cos theta. Plus another cos times sine or sine times cos. Okay, it doesn't matter the order, so I'm going to write it down the same order as this, and then we'll put them together. Okay, and then finally, cos times cos, which gives me cos squared theta. Now, I've got some like terms that I've multiplied that out. This term and this term are the same, so I can put them together. So I end up, since there's two of them, I have 2 sine theta cos theta. And then I've got sine squared plus cos squared. Equals 1 plus 2. Sine theta cos theta. Now again, you should be noticing right away, I've got a sine squared plus cos squared. And even before I did this step, you should already be noticing, okay, I've got a sine squared plus a cos squared. That's one of my trig identities. Okay, so again, I'm going to replace sine squared plus cos squared with 1. Okay, so I end up with 2 sine theta cos theta. Replace this with 1, so it's plus 1 equals, so make that a little more clear. 1 plus 2 sine theta cos theta. So now the left hand side equals my right hand side, so I've proven it. Okay, so not overly complicated, and it's not like it's a million steps. It's just recognizing things when you're doing the algebra. So I recognize right away I've got a sine squared and a cos squared, so I'm going to put them together. Okay? And then these are like terms, so I'll put them together. Okay, so one more example here. Okay. So this one definitely looks a little harder. I'm definitely going to have to do something to both the left-hand side and the right-hand side for this one. Okay, the right-hand side has a sine 2 theta. Okay? And we have a formula for double angles. Tan theta, cotan, and a tan. So all of these have to be changed in terms of sine or cos. So I'm going to be doing 2 different things here. Okay, so the left-hand side, I'm going to start changing that in terms of sine and cos. So this is sine theta over cos theta. And we'll be multiplying that by cotangent squared. So cotangent is going to give me a cos squared theta, a sine squared theta, and then plus tan theta, so I'm going to be changing that into a sine theta over cos theta. And then on the right hand side, you can do them at the same time. I have 2 over, and I look up for my double angle formula for sine, okay, and where do we have it in the classroom? Here it is, and in the classroom right off on my board it is, oops, let's change it, 2 sine theta cos theta. Okay, so all I did here is replacing this by its formula. Okay, so and that's its formula. Okay, so now we're going to move on to the next step. And right away, even before I go to the next step, you can do it since it's right there and obvious. I got 2 on the top and on the bottom, and cancel those. I'm just left with 1 on the top and 1 times this, or just 1 over sine theta times cos theta. Okay, so our next step, okay, I've got some multiplication going on here. Okay, I've got a cos that's going to cancel with the cos squared and leave me just cos theta on the top here. There's sine theta on the top here that will cancel with the squared on the bottom, leaving just 1 sine theta on the bottom. Okay, so these are 1s left over after I cancel. So 1 times a cos theta is going to leave me with cos theta. 1 times sine theta is going to be sine theta in the denominator. Plus, can't do anything with that, that is just sine theta over cos theta. And now it's equal to, after I just cancel the 2's here, it's 1 over sine theta cos theta. And now from the previous video, I had mentioned that one of the things you have to look out for when doing this problems is sometimes you're going to need a common denominator. And this is one of the cases where I need a common denominator before I can add fractions. So going back to the page here, right now I don't have a common denominator, so I'm going to have to make them the same. And this one's sine and this one's cos. And you can already notice that the denominator over here is sine cos. And that's the same denominator I would need over here in order for them to be common. Okay, so what I need to do here then is if this is going to be sine cos, I have to multiply this by cos theta and the top by cos theta. Whatever you do to the bottom, you also have to do the top. Whatever you do to the denominator, you also do the numerator. This one, I would have to multiply it by sine theta, top and bottom. So now my denominator is going to be sine theta cos theta, the same as this right here. Okay, which is what it has to be anyway in order for there to be a common denominator. So if I multiply cos by cos, I end up with cos squared theta over sine theta cos theta plus common denominator again here, sine theta cos theta. And sine theta times sine theta leaves me with sine squared theta equals 1 over Now that I have a common denominator, I can add them together. Okay, so under one denominator of sine theta cos theta, I end up with cos squared theta plus sine squared theta. equals 1 over sine theta times cos theta. So I have cos squared theta plus sine squared theta equals over sine theta cos theta equals 1 over sine theta cos theta. So now the denominator is the same. This one's a 1, this is a cos squared theta plus sine squared theta. There's your trig identity. Okay, the order has changed. It's cos squared plus sine squared, but the order doesn't matter. Think of this. Okay, sometimes if you're looking at more complicated math, okay, change it to something simpler and see if it works. Right? So is 2 plus 3 the same as 3 plus 2? When we're talking about things like this. Can I flip the order around with a plus sign? Will it still be the same thing? Okay, and it is. Okay, so that is the same as sine squared plus cos squared. So using my Pythagorean identity, I can change that to 1 sine theta times cos theta equals 1 over sine theta times cos theta. Okay, so now my left-hand side is equal to my right-hand side. Okay, so those are a couple of the more difficult ones. Perhaps with a little more time later on, I'll put even harder ones on there, or maybe some more in-between ones, just so you can see more practice with these.